goal of this lesson is to determine the equation of a line using the slope and a point, or using two given points. When given the slope of a line A and an xy coordinate, you have all the variables needed to solve for the y-intercept, and thus write the equation of a line in function form, y equals ax plus b. Also, when you are given two coordinates, you are able to solve for the slope, a, then use either of the xy coordinate pairs to solve for b in the function form of a line. Again, you will write it as y equals ax plus b, since you will have a and b determined.
Point. We have a point and a slope. We use point slope. Here they give us 2 points. And we know we need a point and a slope. All we need to do, now that we have 2 points, is just pick one of them. We need to find the slope. How are we going to find the slope? Well, let's go. They give us 2 points. And we have a game plan. The game plan. First, we're going to find the slope. Then we're going to pick a point. We're going to use that slope and pick point in y equals mx plus b, or perhaps point slope, if that's your preferred method. So here, see, we need to first find our slope. Our slope, that's y2 minus y1 over x2 minus x1. Yes, we are familiar with this. So then, until you're a professional, I strongly encourage that you label. This will be x1, y1, and then this will be x2, y2. And it doesn't matter to you which one is your first and which is your second, as long as you keep it straight. So my y2 is 12, and then that's minus my y1, which is 10. Then divided by my x2, which is 6, minus my x1, which is 4. Sure. Finish it. 12 minus 10 is 2. Divided by 6 minus 4, which is also 2. So now what do? You reduce. When you reduce, so you can reduce by a deuce. And your slope is 1. So now you have a slope, which is 1. And you need to pick a point. Well, which point? Ooh, one of the original points. It doesn't matter which you pick, so I pick you. So now we have a slope and a point. That point is 4, 10. And then we just turned it into a problem that we know how to do. With a point and a slope, we're going to put it into y equals mx plus b, or equivalently, we can put it into point slope, which is y minus y1, that's equal to slope x minus x1. Now I'm going to use this one, y, because it's different than the last example, and I want you to have exposure to as many methods as possible. And I think this is consistent with how your book does it. So then here we go. Y minus, what's y1? Oh. Ooh, that's x1. That's y1 as a point. That's my point. My point is that my y1 is 10. And then that's going to be equal to my slope, which is 1. Fun. And then this is x minus. What's my x1? My x1 is 4. Sure. Finish him. Yeah, finish him. So now I'm going to have y minus 10. And then, doesn't change a dang thing, that's that one. It's the identity property. X minus 4. Sure. Now let's put it in y equals mx plus b. And in order to do that, they say, we're going to go ahead and we're going to add 10 to both sides. And we'll add 10 to both sides. And we're going to find that y is equal to, wait for it, x plus 6. And then what? Fox in the flower. It's way too hot in the summer here in California to be shooting these videos. But I'm going to push on through.
Okay, to find the equation of a line given the slope and a point on the line, we're going to use the point-slope form. Y minus y sub 1 equals m times x minus x sub 1. Let's look at an example. If the slope is 2 and our line passes through the point 3, 5, we'll plug in these corresponding values into the appropriate place of our point-slope formula. When we do that, that will give us y minus y sub 1, that's the y coordinate of our point, which is 5, equals the slope of 2 times x minus our x coordinate, which is 3. Now technically this is the equation of a line that has a slope of 2 and passes through the point 3, 5. Yet we typically like to write our linear equations in slope-intercept form, which is y equals mx plus b. To do that, we will first of all distribute the 2, and then add the 5 to both sides. At this point, this is the slope-intercept form of the equation y equal to x minus 1. We can do a check by noting that the slope of this line is 2 by definition. It matches our question. We just need to verify that the ordered pair 3, 5 really is on the line. In other words, if x is 3, we better get 5 when we evaluate the equation. So as a check, we could say y equals twice 3 minus 1. Y equals 6 minus 1. Y equals 5. Verifying again that if x is 3, we really do get a value of 5 for y, indicating that the point 3, 5 is on the line. Let's look at another example. In this example, we have a slope of 2/3 and an ordered pair negative 1, 4. Again, using the point-slope formula, we would say y minus 4 equals 2/3 times x minus the negative 1. Notice I used brackets here because I recognize the negative 1 value for x. As we continue to write this in slope-intercept form, I will first of all subtract the negative, making it x plus 1, then distribute the 2/3. The next step being to add 4 to both sides, recognizing that I will need a common denominator of 3. Instead of adding 4, I will add 12/3, which really is 4. Simplifying this, I get y equals 2/3 x plus 14/3. It should be the equation of a line having a slope of 2/3 and passing through the point negative 1, 4. Again, we can check because the slope here is obviously 2/3, matching our original question. We just need to verify that if x is a negative 1, we really do get 4 for y. Simplifying, we do see that we get 12/3 for y, which is 4, completing the check.